Hi everyone, and a warm welcome to this session today. We are going to talk about the increased importance of AI and machine learning in network design and optimization. My name is Mari Nilsson Björkman, and I work as a global industry lead at SAS Institute for Telecom. And with me today, I have two excellent experts. One is my dear colleague, Sasa Crnojevic. He works as a network AI and machine learning business principal. And I am especially glad to introduce Ms. Teresa Herrero Zamorano, who works at Telefónica Spain as a network strategy and planning manager. A warm welcome to you both.
Hi, Mari. Glad to be here.
Hi. So let us dive directly into this session as such. I'm wondering, Teresa, how have you seen the importance of analytical tools changed in your work?
Okay, analytical tools are for today's networks what data warehouses were for operators 20 years ago. These tools provided us with an easy access to lots of information about network elements. And this information is the basis for all network-related activities, from testing and planning to deployment and operations. But in the last years, our networks have evolved a lot. We have four different mobile access generations coexisting in the same network. For fixed access, we have copper infrastructure as well as fiber infrastructure, and we are providing services that we couldn't imagine 20 years ago. So to handle these complicated networks, we need much more than an information repository. We need analytic tools to understand what's going on in the network and to be able to predict network's response under different circumstances.
Very well explained, Teresa. I can totally see and appreciate that the complexity has really increased since my days at Ericsson. And of course, especially the importance of network quality has increased as well, as it is the connectivity base for the digitalization of everything. So if I then turn to you, Sasha, how have you seen this development proceeding?
Well, Marie, when I joined SAS about 7 years ago, most of our telco projects were in the customer intelligence area, marketing automation, data management, BI, extending to customer experience. But now with this complexity of networks growing and need for further automation to cut costs, actually advanced analytics is completely in the mainstream of every operator. So more and more projects we have with the network department, customer care, risk, fraud, legal, etc. And that's exactly why Gartner in their latest report just published says that the number of communication service providers investing in artificial intelligence for improving their infrastructure planning, operations, and product will rise from 30% what it was last year to around 70% what will be expected by 2025. And this will be the main point so far to the discussion. And if you follow TM Forum carefully, you see that last year they have presented and spoke about the role of challenges of AI operations through in-scope lifecycle changes, which are deployment, production, decommissioning, and end-to-end analytical lifecycle governance. It's very, very difficult to answer on all these challenges without a strong end-to-end analytics partner, purely using internal teams relying on open source or buying a particular product or solution for every problem you encounter, not to mention all the regulations which you need to follow as well.
I'm actually just sitting here nodding, Sasha, because this is really similar to the view I've seen and of what, in the market, the development as such. And I totally agree that it's very tricky to develop and keep the analytical competences in-house. So you really need partners around you for sure. So talking about tricky, Teresa, a while ago, when we spoke, you really strongly pointed out to me that there is no such thing as generic or general AI. You said there's no such thing as a magical solution for everything. Could you please explain what you meant by that?
Okay, Mari. If you read the news, one can think that artificial intelligence can solve any problem and that algorithms are really easy to develop. But that's not true. Artificial intelligence is only suitable for certain kind of problems, and developing an algorithm requires very hard work. Sometimes it takes years. So defining the problem we want to solve is also key in artificial intelligence, because there is no universal solution for anything. From the same training data, you can obtain very different algorithms if you want, for example, to optimize your investment than if you want to predict network failures. And for network operators, it becomes even more difficult because our network is evolving continuously. We are adding elements, we are adding services, we are changing architectures. So an algorithm that works perfectly today will become obsolete in months. And we need to retrain the algorithm with new data to keep it working.
Oh, okay, then I really understand. AI is for sure no magical wand. And it's good that you are pointing out the hard work that is needed to make results. We should not underestimate that for sure. So Sasha, do you agree on that it's needed to have different analytical solutions that are applicable to different business problems?
Yes, Maria, absolutely. I mean, for the reasons that you just heard from Teresa, it's very difficult to pre-build a solution and a data model which can be used in all the situations, even for the same or very similar business problems which they are solving, because networks are so different. So we are indeed better together. And that's, exactly why I think in this TM Forum survey, which was released early in April this year, that talks about automation and AI, 82% of respondents say that they didn't have enough internal expertise to develop the insights necessary for automation, decision making, and closed loop operations. I think the same challenges will face the network equipment providers, as it's difficult to package AI solution in a box that works for everybody. So I really think that you need a strong advanced analytics partner to solve these kind of problems.
Okay, yeah, totally agree that it's a challenge for sure. But how can then SAS supports? Maybe you can specify an example for us?
Yes, of course. I mean, WinSAS can help you deal with those challenges with our software and telco know-how. For example, when you have historical data and root cause analysis, then you can typically use supervised modeling. And if you don't have it and you don't have the root cause analysis data set, then you need to use unsupervised learning for system itself to tell you what is a normal behavior versus the anomalous versus the complete system breakdown behavior. Right? So unsupervised learning is very often used on data streams with many, a few hundred or even more of network KPIs, where humans are unable to tell you which of the KPIs are mostly contributing to the service degradation or service breakdown. And the hardest part in both is actually where humans must be involved, is doing a good and thorough data preparation task, which actually present the heavy lifting in a typical project.
Oh, that was a really good example, Sasha. I mean, being able to know when to use supervised or unsupervised learning, it's really important. And I'm also really glad that you pointed out that you really need the extensive and thorough data preparation in order to get this right. So many angles to consider, Teresa. What would you actually, in your opinion, ask from an ideal AI or analytical platform?
Okay, to handle our complex networks, we need easy-to-use tools for inference and analysis. Our network experts must be focused in analyzing data, not on programming complicated algorithms from scratch. And for this reason, it's so important to have a common environment for analytics where it's easy to share code and data, and where the most basic problems and needs are solved in a native way.
So what I'm hearing is a common environment for sharing and easy to use tools. So it's less programming from scratch, right? So if I then ask you, which methods would you recommend, in your opinion, to utilize in the networks?
Okay, different problems will need different approaches regarding the methodology we are going to use. Some years ago, we developed an algorithm for mobile access demand prediction, and it was based on traditional statistical tools and works perfectly. But when we were faced with the challenge of developing a similar algorithm for fixed access and IP networks, we tested different options and finally chose an artificial intelligence based algorithm. It's the characteristics and the internal dynamics of each problem which defines the best methodology.
Okay, so for me, if I understand this right, it sums up that you really need the agility. You need to have agile experts, process people, organization, everything in place. But also it sounds like a bit like a never-ending cycle, but I don't think in a negative way maybe, because it seems like you are reusing your methods, your findings, your results, and really feed that into the next new area that you are exploring, which is good because then you will reach faster results for sure. So, talking about results, Teresa, do you have any results that you are able to share that you have accomplished with this approach?
Well, to plan network upgrades in mobile access, we apply the expected traffic growth to every site and then calculate if we need to add capacity to handle this potential future traffic. Before developing our current algorithm, we use a common traffic growth value for every site in the same province. But thanks to our new algorithm, we can handle a personalized traffic growth value per site. And well, if you have a look at the slide I'm sharing, you can see that the mathematical distribution of traffic growth per site in the network is enormously skewed. So we have improved a lot our investments by using a personalized traffic growth value per site.
So, it's really, really crystal clear when you see that slide, right? That, it's a really good example of smart CapEx for sure. Having a granularity on the traffic growth per site makes all the difference in investment figures for sure. So, Sasha, have you any numbers that you have seen with other operators when you have worked with them?
Yeah, you've heard Telefónica's experience of smart network planning, and on network operations, I can add that proactive maintenance, moving from reactive to proactive maintenance, can save up to 25% of field operations cost. And the use of computer vision and AI what-if scenarios can save up to 5 to 20% for design and optimization of access and transport network, depending on the use case. Yeah.
Well, that is a really good, strong numbers, I would say, because as we all know, high percentages means millions in money. Thank you for sharing that, Sasha. So if we then leave the results aside and then change into the topic of implementing these new ways of working and the new tools, what does it mean really, and how is it done? So Sasha, have you seen any successful examples on how this is done by an operator that is sort of marching in the forefront of this transformation?
Yeah, that's a very good question. You have many management consulting companies that expertise in these kind of people and management organizations to be able to run most efficient business operations. However, what we have seen working with some communication service providers in the Nordics area, for example, is that until they were able to find a bridge and hire the right kind of profiles to be the interface between their network teams, operations and strategy planning teams, and their big data team, they didn't really know how to get the value out of AI and machine learning systems for the network part. And this comes with its CSP's legacy, where network teams are used to buying a solution in a box. In the past, it was a black box. In the latest date, it's more kind of white open box, but still they are buying a solution for every problem they encounter. Just look at TMAP, for example. While their big data teams usually come up from academy or programming open source communities, so it's difficult to build enterprise-ready solutions if you don't have so-called business analyst roles that they are bridging this gap, which understand both worlds and can detail the business requirements of the network people towards the big data team. Of course, C-level management for that kind of organization is crucial to make.
And what you are describing is very much, two different teams, network and data analytics, and of course, how different they are solving their challenges and how they are working. So I can totally understand that it's very crucial to have the C-level sponsorship in order to enforce this joint approach so they start working really together and in the same way. And Teresa, this is quite a challenge, but I know you have been doing this and experienced this firsthand. What did you do and how did you make it work with your team?
Well, in Telefónica, we began years ago to learn the basics of analytics. So our engineers are using analytic tools to understand what's going on in the network. This has substantially improved our knowledge and our capabilities for network-related activities. And when we are faced with really complicated problems, we can ask for help to analytics experts, because now we are able to explain to them what we need, and we have a clear idea about what to expect from them. And knowledge is 10% formal, 20% social, and 70% experiential. So through all these projects that we have developed together with analytics experts, we have created a common ground, a common language, and we have improved a lot the way to work together.
Thank you. That was really interesting, Teresa, how you have worked by, I would say, learning by doing in a way, right? But also, again, you are emphasizing the hard work and also a lot of time invested in really creating that bridge and translation between the different equally needed, I would say, skill sets and teams, right? So thank you so much for sharing. So, Teresa, do you have anything to conclude? I would like to conclude this to the audience with 3 key lessons learned on your road to this or your progress to this.
Yes, of course. Well, the first one is that to handle today's networks, you need to combine networks expertise and analytics expertise, and you need to create a common ground for this cooperation. The second one, networks are continuously evolving, and the technical solutions differs a lot from an operator to another one. So there is no universal artificial intelligence algorithm valid for any network. And of course, there is no future-proof algorithm. We need to continuously upgrade our algorithms to keep them working as the network evolves. And third, and most important, you cannot handle a 21st century network with 20th century tools.
Oh, those were excellent, powerful, I would say, last words of advice. So thank you so much, both of you, for a very enlightening and open discussion. And I, for sure, and I hope our audience as well, has truly appreciated you sharing your real life experience with us. So thank you so much, and adios and goodbye.
Thank you, Mari.